Okay, so is everybody in? We got some. Okay, so now we're gonna have our students present, and our first group of students are students who participated in SEE3 at UH Manoa, and so our first group is Lorraine Nabua, Arvin Niro, McClyde Gaborno, Sato, and Darren Ramos, who will be presenting the creative design suite.
It's a 10-minute presentation, so Jasmine up here will let you know how much time.
Is it 10 with questions?
10 and then questions.
Done. Thank you.
Okay, first of all, thank you everyone for coming to our presentation today. Thank you for coming. I'm Isaiah. This is
I'm Lorraine.
and we're going to present on a learning center that the entire SEE3 program worked on this summer.
Yes.
So, first of all, NHM, the Native Hawaiian Science and Engineering Mentorship Program, they got a room in Holmes Hall, which is the engineering building at the University of Hawaii at Manoa, and they wanted to remodel this room and turn it into a learning center for students to work on computers, have tutoring sessions, like do study groups, and basically just have a study room and a relaxation room where students can decompress. So we had to decide on a name for the learning center, so the SEE3 program decided on Creative Engineering Design Suite, and we chose this name for two basic reasons. The first one is that we have 8 computers in the room, and we built them, and they're very high-tech computers, and we'll talk about it later on in the presentation. But these computers will have a lot of software that will support creative engineering design that the students will need for upper-level classes in the engineering department. And we also chose the name because it's a homonym with seats, which symbolizes growth, and that's basically what we want in the room. So this is the basic process that we followed for creating the learning center. We brainstormed, and then we had to do purchase orders, purchasing material, computers, furniture, paint, pretty much all the material. And then we did the manual labor side, which is remodeling. So we had everyone in our program just like painting, cleaning the floor, redoing the flooring, and basically. So for the brainstorming group, we split into groups where we thought about what kind of furniture you needed, how much you needed, the hardware you needed, software. So software, we tried to decide on which programs we wanted to have on our computers, and like hardware, we decided if we wanted to have like a refrigerator or a couch, or how many whiteboards we needed. And we also wanted to look at what do we want the room to be used for. And we also made sure that we had the study necessities available for students.
Okay, so part of what we did to stay on task was we made a Gantt chart. So a Gantt chart basically shows our tasks represented by the bars. So, and on the top we have our timeline. So each bar represents a task, and the start of the bar represents when we started and how long it should ask for, and then it ends. And so we use this to help stay on track with our project. And so to design the room, we use SolidWorks for the layout. So SolidWorks is a 3D computer-aided design program that helps you make whatever you're thinking about, your ideas, come into like a virtual reality. So you can customize your dimensions and choose the materials you're going to use for your object or project. And so we use this to create our rooms. We made renderings of what we wanted to look like. So we use an add-on on SolidWorks called PhotoView 360, which it makes a realistic image right here. And so we have different layouts for different uses of the room. On the bottom right, we have a conference layout where students can like gather together for a presentation. And the upper right, we have just like a lounge area where students can come to study or hang out with friends and like use the computers for whatever they need to.
So as Isaiah and Clyde said earlier, we have computers inside our room. And So there's a total of 8 computers. They're all hand-built by the students of the program. And what's nice about these computers is the components that these computers have are probably the most up-to-date and top-of-the-line products on the market today. It features things such as an i7 core processor, 4 16GB RAM cards, an NVIDIA graphics card, and they are water-cooled as well. And the benefits of having these components, they allow the software, such as SolidWorks and MATLAB, they allow the software to run efficiently and smoothly. As you saw in the previous slide, the renderings that McClyde did for the room that you saw, those were done on the computers in the senior design lab at Manoa. The problem with that was that the computers didn't have enough computing power to handle the, I would say, the running program. And so these computers are going to be able to make the students see the results of maybe fluid analysis, strength analysis, performing them on SolidWorks, or even programming. They can see the results instantly, and the computing power of the computers will provide these for the students to learn and also experience these programs, because these programs are not available on campus usually. Like if you go to the library, you wouldn't see SolidWorks installed on the computers because they're very high-intense programs. And so by having these softwares installed on these computers, we have students come to the room and learn SolidWorks or programming and such.
So this is how the room originally looked like. The picture to the right is the front room, and then when you walk in from the front door, there's going to be a hallway to the right which leads to 2 side rooms and a back room. And this is us.
This is us basically working on the room from there. So we repainted the roof black so you can't really see the depth and kind of the mess back there. And then we also repainted the doors. We redid the flooring. We put vinyl on the flooring over that, and we basically did everything we could. We couldn't really move the fire hydrants and the fire extinguishers. Yeah. So this is the first step of our process, basically. Okay. So that picture on the top right is when you first facing the room. So that's the picture that you saw on the left before, but now it's more full and there's the computers in there. So this is basically the front room where we want to have more study going on, and there's the 8 computers that you can see, and desk space and whiteboards. So this is where we are as of now. This picture is taken earlier this week. So these are the other.
This is the hallway leading to the back rooms. The picture to the right is the hood, which is in the back room. We don't really know how to get rid of that yet. And this is just a SolidWorks layout of the room, which is what McClyde showed us earlier. So for the room, current use of the room right now would be tutoring sessions. We recently had an ACES meeting for it as well, which is the pictures on the bottom. And we use it as a study area.
So the room, of course, isn't finished. So future work, we want to put security in there because those computers are really expensive. We don't want none of those walking away. Sadly, all the software for all the computers. We want to get a projector and a projector screen in there for presentations, and maybe a fridge in the back or a couch, something just to relax, and overall create a place for all the students to come. I'd like to thank the National Science Foundation, the U.S. Department of Education, Native Hawaiian Science and Engineering Mentorship Program, Pacific Mechanical Technologies, UH College of Engineering, Department of Hawaiian Homelands, Kapiolani Community Development Corporation, and all our ʻIKE program coordinators, our research mentors, and all our school tutors.
And we'd also like to thank lots of the members in our group who aren't presenting today. We're simply the presenters, but all the ʻIKE or the SEE3 workers working on this room. So it's not just us 5 doing everything. So is there any questions?
Sorry, that was the big
Yes, sir.
I have a question. What are water cooled computers?
What was the question?
Water cooled computers? How does that work?
Okay, so basically, water cooled allows, instead of using a fan to cool off your components, water cooled uses a special system where it runs a fluid, a cooling fluid throughout the whole entire system of the computer. And this is good because it keeps the components of the computer nice and cool. Because when you're using computers that have this much computing power, it's important to have them cool so that they don't overheat and they don't cause problems and such.
So basically, it's much better than just the fans that are in normal computers. It's a lot faster cooling so that we can get a lot more computing going without it overheating.
And they last longer. They keep the computer lasting longer.
So is it connected to a faucet and a drain?
Oh, no. It has its own system built in. So it has its own, it flows inside the computer itself.
What was the approximate cost of those machines?
Altogether?
No, just for one?
Just for one? About over 4,000.
And that was when we built it. So if we actually purchased them completely built, it would have cost more than that.
Thank you.
I was curious how much experience you have with the high-end software programs like SolidWorks and those prior to being in this program.
Well, lots of us in the program now are going into their third year, junior year, so we're kind of starting into where we start using these programs more often. So most of us are not that comfortable using them yet, but we definitely will be using it later. I know lots of grad students that use SolidWorks all the time, and it's something we would need to become comfortable with and have access to as engineers.
And a lot of students who are part of the ʻIKE program usually touch on SolidWorks. Like if you're in ʻIKE 1 or like C1 or C2, usually you use SolidWorks either in the guitar making or the Lego cards. And so for some of us, it was something we were familiar with, but for others, it was completely new. But there was tutorials and some guidance to help us learn the basics of it.
They're in Holmes Hall.
It's Holmes Hall 458, so it's on the 4th floor. It used to be an electrical engineering lab.
Any more questions?
Okay, so our next group who will be presenting. Oh, so the next group is another SEE3 group of students, and it will be Ka Hana, Ramos, Arvin, Akuna, and Isaac Lam. So let's give them a round of applause.
Hi everyone, I'm Isaac Lam. I'm an electrical engineering student, junior at UH Manoa.
I'm Arvin Akuna. I'm a mechanical engineering student at UH Manoa. I'm a junior as well.
Hello, I'm Ka Hana Ramos. I'm studying mechanical engineering and I'm at KCC.
And today we'll be doing a presentation on Project Kapiolani, which is Hawaiian for the wind. So, the vision for the project was to create a net zero energy source for Papakolea, and we wanted to do this as a project that would give back to the community for giving us the time to do a project for them. And we wanted to do it as an actual project that would give back to the community, as I said before, and not just as a demonstration project. So hopefully it'll have a long-lasting and real impact in the community. And for those that do not know where Papakolea is, it's the red dot on the map, and you can see it in relation to UH Manoa as well as that bit.
So we decided after researching that to make a wind turbine would be a lot more headache and cost than it would be to just get one. So we went with, we researched and we went with the Air Dolphin GTO made by American Zephyr. Wind power isn't very popular because the amount that it costs for what it puts out, you might as well just go with solar panels. So in order to tie it to the system, it's a little more difficult to tie it with a regular inverter that you would use with a solar panel. So this one uses an inverter that the solar panel would normally use to convert it back to AC and put it into the grid. So this wind turbine, some of the features, it's made for more urban communities. It's 6 feet in diameter. It's made out of aluminum blades with foam and carbon fiber over foam, and the body is plastic and aluminum. It has this SD blade technology. It has little grooves on each blade, and what that does is it holds the wind to the blade a little bit longer so that the turbulence only comes off the back and not around the whole thing. Same thing with how an owl was modeled after an owl. An owl has the same grooves in it. Also, there's little serrations at the end. So instead of having one big turbulence at the end of the blade, it breaks it up into little mini ones and makes it quiet. That's why owls fly so silently. This is our budget. We were supposed to get it for a cheaper price. It's usually like $7 grand in some websites. This is our inverter. The Windy Boy is the inverter, and I'll talk about the monitor and the inverter a little bit. The poles and the wiring, we were going to put it on top of an elevator shaft in the Papakolea Community Center. So that's the cost of the mounting. So this is some of the specs of the windmill. It should produce about 1 kilowatt hour given the wind in Papakolea. We'll talk about the wind speed in a little bit. It has a cut-in speed so that it uses some of the powers that it had built up from spinning earlier, so that when the wind goes down, it takes less start speed to get the blade to be spinning to produce more power. It can go up to 4 kilowatt hours, up to 4 kilowatts per hour when there's 44.7 miles per hour wind. That's pretty fast. So this is our inverter. This is what's going to be putting power back into the grid, so you actually get money back from your electric bill if you go over, if you don't use as much as this thing can produce. We can control this from a phone somewhere, given that Bluetooth and the wireless. This monitor will be mounted near the windmill. It has powered all on its own. It'll tell us what the wind speed is, the temperatures, and how much power it's producing. And once again, we can hook this up so that we can watch it from that learning center via computer.
Okay, so to get an approximate idea of what kind of energy we'll be able to output with this machine, we use the ʻIKE wind map. It was put online for our use. And we got a zoomed in view here of Papakolea. It's right under that big blue arrow. And based on the key, there's like a key for this map in the upper, I think that's the left corner, your guys right. Based on the colors and the way you read the map, we got a estimated 15 mile an hour average wind speed that we'd be getting. So that's what we use to make our approximations. And using this graph that Zephyr provided along with it's like in a pamphlet that you would get when you buy the windmill. we would probably be getting 15 miles an hour as an average wind speed. So it tells us that we would be getting annual energy production of 3,000 kilowatt hours. And when I first heard that, I didn't know what it meant because I don't really know what a kilowatt hour is. So to put it in like a practical, like what you would use it for, it costs about 30 cents per kilowatt hour we use on Oahu. And if we were gonna be producing 3,000 kilowatt hours, we'd be saving the Hokulea Community Center $900 a year. And this fridge produces, uses 577 kilowatt hours per year. So you could maybe get like 5 of those going, and you could, pull some drinks and have a nice party. So, that's like a practical look at what's going to be going on. I can't really use it. I don't know. This is the way it worked for me.
So we would like to give some acknowledgments to Department of Hawaiian Homelands as well as Papakolea Community Development Corporation for allowing us to work and visit Papakolea. And we also like to thank the National Science Foundation, the Native Hawaiian Science and Engineering Mentorship Program, and the American LED and Energy Corporation for giving us the backing to research this project. And we also like to thank the SEE3 mentors as well as our fellow students who worked on the project. However, though, we faced several setbacks when doing this project. The wind economy, I guess you could say, wind energy economy, is somewhat small in Hawaii compared to the solar economy or solar energy economy. Because you see, solar ads on TV all the time, but you never see wind ads. That's because there's not really a whole lot of wind energy companies out here. And the suppliers that ship from the mainland would not ship their parts out here, so we were not able to do this project as of now. But however, we still plan on doing something with Papakolea in the future. Questions?
Being that this is an Indigenous Knowledge and Engineering Conference, what is some of the issues from the community perspective and knowledge paradigm of implementing wind energy in our community?
They seem to like the idea a lot. It was just safety was one of them, because it's at a community center and it's pretty easy for kids to climb on the roof.
But when the first one's operation, so like when that does not want wind power, why?
From what I don't really know exactly what those guys are doing, but from what I understand, it's gonna, I participate in hunting. So a lot of the hunters, it would be taking away the opportunity for hunting in the area because you can't have guys shooting your window. So, and that, they probably, there might be burial things. So, for the you guys, there's quite a lot of reasons. But for Papakolea, one of their concerns was like a nice view. It's a beautiful place. And so putting this, we would just put like a huge, tower there. It would be like an eyesore and be bothering people. But this is a small system, and that was really like the only important, not important, but the only big concern that there was. Other than that, I don't know that culturally or anything, it wasn't that offensive.
Well, I think we should talk to people.
I was curious if you folks partnered with a local company to maybe get some mentoring and advice.
Well, we went and tried to talk to, we didn't try, we went and talked to a company that provided this turbine, and that's how we intended to bring it in. And so he gave us all the, well, not all of them, but the recommendations on which inverter to use, and he shared his experience with us as far as picking the parts and as when installation would have come into play, but set that. You try to find.
How come we don't have a civil engineering student on board?
We did. We weren't the only ones working on it. It was also the rest of the SEE3 team.
You have CE
Yes, we do.
You didn't address the foundation, the environmental impact statements, that have the studies that have to go before building such a structure. You might be killing endangered birds.
I checked on that. We did check on to see if there were any permits for if there were endangered animals in the area. It's also not a very big windmill, so if it was one of those the Hana Ka IKE, that would be a problem for us. But this is only 6 feet in diameter, so there wasn't too much permits to go through. As far as foundations, we weren't going to cement it. We were going to mount it to the elevator shaft. Because it was in the ground, somebody's going to climb up and get their fingers lost.
Taken care of. Maybe like you would say, oh, you should buy these things, and after you have your total purchase, and then maybe 10% of whatever it costs. But just showing them the tools, giving them the map to see if it's even a viable option, and then telling them realistically, power 5 fingers.
Oh, it's kind of small because of the fact that it costs a lot of money for that, and solar panels do the same thing. That's why it's not relatively massive.
So what's what's the selling point then? This wind over solar for the?
Well, they're getting solar panels. Community center is getting solar panels all over that whole thing. So just something to complement that, something a little bit different. It wasn't more for its practical purposes. It was people can see. You can't really see the solar panels. That wind turbine would be everywhere. We show that we're trying to stop using so much. And also for at night when there's no sun. Yes.
That's true. But I'm sorry, another quick question then. So the idea here is to basically, is this to be used by the community centers on Hawaiian homelands, those communities or individual homes, or how do you foresee this?
So for this specific project, the community center had this initiative to go net zero for their energy consumption, and they would be like a role model or an example for the rest of the community to hopefully follow. But yeah, just for this project, I don't know that we got so far as to implementing this across all of the Hawaiian homes yet. Maybe we could be nice to do that and help out. But yeah, so the solar panel was going to be the main energy provider, and then the window is just like a supplemental thing, but at the same time, it would be like a beacon for the community to see and be interested and aware of renewable energy.
I think a lot of the pushback and a lot of the controversy surrounding wind turbines and all that, aside from the visual aspect, it's just where the energy is going to. It's being exported to one community, over another, or whatever. So, if it's something that would directly power, that particular community, that might be very supportive.
I agree.
We think it does power whatever This one is not very big, so it's going to be at solar panels too, but whatever doesn't use the power that it goes back into the grid and then they get a credit for it on the electric bill if they go over it.
Okay, so just so that everyone knows, if you guys have more questions for the presenters afterwards, like during lunch, please feel free to talk a story about and get to know more. So our next group will be an electric vehicle, Aquaponics Station by Lyra Hancock, Ryan Saito, Brandon Santiano, and Thailand I.
Hello everybody, my name is Lyra Hancock. I am going to be an electrical engineer. I currently go to UH Manoa.
Hello, my name is Thailand I. I'm a mechanical engineering student at UH Manoa in my 3rd year.
Hi, I'm Brandon Santiano, civil engineer at UH Manoa. And Ryan Saito is not here. He had to be called in for work today, but he's a mechanical engineer now at UH Manoa.
We will be discussing our aquaponics project that we did this summer on behalf of our SEE3 program. Okay, so we chose aquaponics. This was actually like in the last stretch of our program, so within the last 2 weeks. We decided to do aquaponics because we wanted to do like a sustainable growing method. We were also interested in adding it to the creative design suite, and we wanted to have like a practical use for it. We also, or at least I know Brandon and I had a general interest in like growing fish and plants together. So this is just a general idea about what aquaponics is for those of you who don't know. It's just like a continuous system where you have like a tank filled with fish or shrimp, and the water from that tank gets pumped up, or wherever your tank or your bed, of vegetation is. You can have plants like pretty plants like flowers, or you can have something to eat. A lot of people use it to grow like food, like vegetables and things like that. So that's just a general idea of how aquaponics works. Okay, so this is like the cycle of how everything is. Like the fish or whatever marine life you have in your tank, like they excrete their waste, and then the waste and the decomposed food turn into ammonia. That ammonia then turns into nitrites, and then the nitrites get turned into nitrates, and then that water gets pumped up to the plants, and then the plants absorb the nitrates, and that's what gives your plants the nutrients it needs.
Okay, now as you see here, this is our Gantt chart, which is our timeline which we try to follow. And this bar down here, the way bottom, that is a 2-week span period where you can see that it goes to the end of the ʻIKE program. And as you can see, we kind of fell out of the prospective time period, but that only means that the aquaponics is still in progress. Oops. Now, researching aquaponics, we kind of made this list of the more important components required into building an aquaponics system. And I didn't really know much, but there's so many different varieties of how you can run an aquaponics system, including like continuous flow method or the CHOP, constant height, one pump method. But we kind of went into the continuous flow, as you will see in some pictures that we have. And we would want a grow bed of 135 gallons. So it's going to be 8 feet by 1.5 by 1.5. So it's actually pretty big when you're up close. And to help with the nitrification and denitrification process for helping the fish and plants, we would implement BioBall's media filter, which kind of like, promote growth of microorganisms to help with that.
Okay, so we started with a budget of $5,000, and this is how we chose to allocate our funds, minus the fish and the plants. So a couple of things, that's actually 70 cents, not $70, because that would go like $65,000 over budget. And and the stand. Actually, we purchased the tank and we custom built the stand. So our total was about $1,100 under budget, minus the fish and plants, so that's how much we have left to spend. And this is a part of our planning stage. We got to utilize the seed suite that the other group talked about earlier. We got a bunch of whiteboards, and a part of the engineering process that we had to learn was hand drafting. They have all these computer-aided design programs, but one of the first things you want to do when you're brainstorming is draw it out. So the top is actually the drawing of how our stand, how we chose to model it, and then the side view of the tank and the stand and the tray and the lights. That's how we wanted to model our system, and a few dimensions on the other side. So this is a rendering that one of our students actually did, Jeff. He did a Google SketchUp on the top, and then the bottom is of the stand, and that's obviously hand-drawn. And we got to utilize SolidWorks in the senior design room, and this is actually the stand and tank that we decided to use, and that's the completed one with the dimensions you can see at the top. That's the ones that mechanical engineers and civil engineers use SolidWorks a lot of the time in their projects. And here is the stand that we actually got to build with our mentors. We obviously don't want to have beginning welders welding it, so we didn't do all the work, but we got to help fabricate the pieces of metal that needed to go with the stand, and a couple more views of the stand. And that's our tank, which we ordered, that was custom built for us.
Okay, so after the aquaponics system is built, obviously we're gonna have to put plants and fish in it. And we've been looking up like a really good fish would be the tilapia. You know, it's commonly used in aquaponics because they're just so efficient. And since we planned on having this in the seed suite, we kind of have to go. Nobody wants to look at tilapia all day, so we have an option of an aquarium fish. That's a red discus at the bottom. But there are other ideas in the program where we want to implement more of our culture and our roots, so kind of catering more towards native plants and fish or indigenous. And these will be the examples of the palapalai, the ihi, the popolo, I don't know if this is shrimp, I forgot the Hawaiian name, sorry, or the o'opu right here. That's a stream guppy that we can get from local streams like in Manoa. But we can't do that yet because it's still in progress. But hopefully the aquaponics station can be done. We're hoping to shoot for it pretty soon so students can start using it. People will be able to use it for research or just finding out, learning things. And we really couldn't have done this all without, our program coordinators, our mentors.